Imagine you are reading a book. When you look at the page, the words are already there, right? Reading them doesn't change the story. That is how your laptop works. It's how the entire classical world works. But in the quantum world, the act of looking changes everything. Hi everyone. Today we are breaking down one of the most confusing concepts in quantum computing, measurement. This isn't just about checking a value. It's about forcing nature to make a choice. Let's dive in. To understand measurement, we first have to look at what happens before we measure. In classical computing, a bit is like a light switch. It is either definitely OFF or definitely on. If you look at the switch, you just see what state it is in. Simple. But a quantum bit, or qubit, is different. Before we measure it, a qubit exists in a state called superposition. Think of a coin spinning on a table. Is it heads or is it tails? While it's spinning, it's actually a blur of both. It holds the potential to be either, but it isn't one or the other yet. This is where measurement comes in. In the quantum world, measuring is exactly like slapping your hand down on that spinning coin. The moment you measure a qubit, you force it to stop spinning. You force it to choose. It instantly collapses from that magical superposition state into a single, boring, classical state, either a 0 or a 1. And here is the crazy part. Once you measure it, there is no going back. You can't make it spin again just by looking away. You have destroyed the quantum information and replaced it with a simple classical answer. So, how does the computer decide if it's going to be a 0 or a 1? It's all about probability. When we program quantum computers, we are essentially weighting the coin. We might prepare a qubit so it has a 50% chance of collapsing to 0 and a 50% chance of collapsing to 1. Or we might use interference to make it 99% likely to be a 1. But we never know for sure until we actually look. Measurement is the final step where we ask the universe, okay, stop the possibilities and give me a concrete answer. To summarize, measurement is the bridge between the quantum world and our world. It takes a qubit that is in a mix of states and snaps it into a definite reality. It's powerful, but it's destructive. That's why quantum algorithms do all their complex math before we measure, while the coin is still spinning. If you want to understand how we get that coin spinning in the first place, check out my next video on superposition. Don't forget to like and subscribe for more generative AI and tech breakdowns. See you in the next one.